Hi everyone. In today's podcast, we have Enrique Apolo, who is a postdoctoral researcher in the precision scoring group at Ghent University. Also, he is one of the current pioneers building his research interest around artificial intelligence, precision agriculture, proximal soil sensing, satellite imagery, machinery, robotics, and electronics. This is a brief episode covering Enrique's recent Ph.D. dissertation. So in today's podcast, we will discuss about drone imaging and implementation of AI for detecting agronomic traits of fruit trees and field crops. Hi, Enrique. Thank you for being here today.
Thank you so much, Enrique. Thank you for the invitation. For me, it's a pleasure to be here. I think so. It's the first time I'm participating in a kind of podcast like this, and in English, of course. I participate in Spain. I'm from Spain. So thank you so much for the invitation, and let's enjoy in this interview.
Yeah, thank you for agreeing this to happen. Can you please give a brief introduction about your academic background and also your current research works?
Okay. Basically, I did my bachelor degree in Spain in the School of Agriculture Engineer in Seville. I started doing my bachelor degree in agriculture engineer, and after that, I did a master in crop protection, focus on how to implement tools to protect the crops against the disease, against the insects, against the weeds as well, everything related with the crop health, And after that, I did another master in geographical information systems, and that gives me the opportunity to learn more about how to work with the satellite images, how to work with the drone images as well, and that's the reason I'm start to think and researching more deeper in that sense. And after I finished that master, I start my PhD. Basically, my PhD was focused on artificial intelligence, but in two topics to be more accurate in that sense. It's like one is about how to use the artificial intelligence in orchards, and the other one is how to use the artificial intelligence for phenotyping purposes. Mm-hmm. So, basically that's the brief introduction, and then I can explain a little bit more about specific details.
Yeah. Also, for the listeners, Enrique is also a postdoc at Ghent University in precision scoring group. Yeah. You can later on. We will also give a brief introduction about his current work. So last year you defended successfully your PhD. Congratulations.
Thank you.
Yeah. Also, when I was preparing for this interview in one of the online sources, I don't remember where, they described your PhD dissertation as outstanding work.
Yeah.
So really, congratulations on that. So maybe you can tell us more about your PhD work. Why implement AI in orchards, and what are the ways of implementing AI in this area?
Yeah, in Spain, when we start with my supervisor in Spain about thinking how to use artificial intelligence, it was we talked with the farmers. And the farmers told us we have this problem. In Spain we have a lot of citrus orchards in the south of Spain, like orange, mandarins, and lemons, all that kind of things. And in Seville, specifically, we have a lot of citrus. If you visit Seville, you can see in the streets even. So the farmers say we need a tool to predict the yield, if it's possible based on drone images or another tool. So that was the reason why we start to think and how to use the artificial intelligence and citrus orchards. And moreover, we have the opportunity to talk with plant breeders, and they are focused on wheat crops, especially wheat and barley. And they told us as well, they need to accelerate the breeding process, because sometimes they need to take a lot of measurements like the plant height, leaf area index, all that kind of things. And these tasks are very time consuming, and you need to find tools or ways to improve that process, So that was the beginning of my PhD.
Okay.
Yeah.
To explain it more, you've been working in two first orchards,
Yeah.
the mandarin and also other fruits. Second one is wheat and barley.
Wheat and both crops, but we focus on wheat. Just one of my papers for my PhD was focused on wheat. Yeah.
Okay. And this has been a pioneer approach, as I understood.
Yeah.
Okay.
Yeah. Basically, in the plant breeders take a lot of measurements, as I told you. So one of the key parameters for the crops is the leaf area index. So they wanted to know how to estimate the leaf area index. The leaf area index basically is the area of all the leaves belongs to a plant, for example. You can measure in two ways, indirect methods and direct methods. The direct methods is just you need to cut the leaves from the plant and use a kind of planimeter, and you can measure the leaves, the area of the leaves, using a kind of sensor. But you cannot do that with all the plants. That's the way to measure very accuracy. So, but it's impossible to do that with in the crops or
for each plant you're going and measuring.
Yeah. So that's the reason why some researchers are looking for new approaches to estimate the leaf area index, and they use basically two methods, using RGB images or sensors to measure the light interception from the sun. As you can put a kind of sensor below to the plant, and you can measure how much light is coming from the sun. So based on that measurements, you can estimate the leaf area index. But sometimes these instruments as well, you need to measure in each position of the crop and a lot of points. So it's time consuming as well, and it's not suitable. So our idea in my PhD was to use a kind of robot, a small platform robotic, and we put a mobile phone on the top to take pictures at 15 minutes, each minute more or less, or each second. It depends on the crop. And basically, we use the images from the top to train a model to estimate the leaf area index. But that was basically just using an RGB image to estimate the leaf area index.
Okay. Yeah. So as I understood, you put onto the robot the camera.
Yeah.
And then the robot goes.
The robot was traveling through the crop, taking pictures. We took the ground truth value for leaf area index on that points as well. Okay. We have to do the way I told you, cutting the leaves to have the ground truth as well.
Exactly.
But we did that just for training the model, because our ideas in the future, actually this company, because we collaborate with a company there, a breeding company. So they are using this technology but just using the mobile phone, or you can use another camera as well. It doesn't matter. It's just an RGB camera from the top. So you can estimate the leaf area index.
I see. So basically, you could use it as I understood, in orchards at the same time. Because for me, for wheat, it seems going with robotics in the field, it seems a lot of work. Did you use this same technique in the field? Did you use the robots, or did you use the tractor, or how was it?
The reason why we used the robotic platform was because we applied for a project. So the government gave us the money to build this kind of platform, because sometimes you cannot, the plant breeders plan the micro plots, because it's not like for commercial field. It's just for plant breeders. So they used to plant small micro plots, so you cannot go inside with the tractor sometimes. So we need to build a specific robot to go through the crop, through the micro plots in this case. So, but if you have a machine able to go into the micro plots, you can put the camera as well, or you can build a kind of metal frame to put the camera. It's just the unique requisite for use.
I see. I remember us talking when I just started my PhD. I was asking about your work, and you told me that you have learned a lot during your PhD work. At the beginning, you had to learn by yourself a lot of things. So could you tell us, like, when you started your PhD, what kind of skills you've learned? And also, I know that you did some practical works in Wageningen University. How was that experience overall?
Yeah, I think so. When you start the PhD, it's like for everyone, I think so, it's more or less the same, because it doesn't matter where are you coming from. I mean, the bachelor. So you need to learn everything from the scratch, I think so, or adapt your background to the new group sometimes as well. So when I finished my bachelor, I didn't know anything, to be honest, about artificial intelligence or sensors or remote sensing. I was very interested in the new technologies. I loved the computers when I was 12 years, I think so. I have my first laptop. And so in that moment, I like this. And that's the reason why I started to work with the new technology. So basically I have to learn everything, mainly from YouTube. I have to watch a lot of videos to learn how to
That's very true.
program. Yeah. I think everybody do that. So I, I, I do a lot of things, just practice and error, practice and error. So for example, I have to program some Arduino electronic boards, for example, to connect all the sensors. I have to do myself. I have to call a lot of people to say, I have this sensor. How it works, this sensor? Can you explain me which is the outputs of the sensor? So I have to do that kind of things. Yeah, but I think so. You are doing the same more or less in your PhD
exactly.
now. It's like
I can relate 100%. It's true what
yeah.
you're saying.
So in that point, one of my best advice, as I'm a younger postdoc now. It's like just a few months ago, but I think you need to be proactive in that sense. When you start a PhD, the supervisor is just they give you the guides to follow your PhD, but you need to be responsible as well, to make decisions, because I think the most difficult task when you're doing the PhD is make decisions, this is right or not right. So I think so if you strongly believe in you, it's pretty important, I think so. Just
yeah, that's also why it's your PhD actually.
Yeah.
You are the person who is doing the PhD.
Yeah. You will have to defend the thesis. Nobody will do that for you. It's like
yeah. In the defense, you are not just going to say, "Oh, it's because I didn't give a
no, it's
good
not my
supervision."
supervisor told me that. No.
Exactly. So, could you also talk about you've started your research in Spain, right? In Seville, and then you had to go to Netherlands.
Yeah.
And there.
Yeah. So, when you're doing the PhD, you also attend to conference and that kind of thing. So I attend a conference in 2018, I think so. No, 19, before the pandemic. So I met there a guy working in Netherlands in the Wageningen University, working with drones and orchards as well. And I talk about my research in Spain with the citrus orchards. And he told me, oh, okay, I'm interested because I wanted to do the same with apple orchards. So basically, I went to Wageningen to replicate the same experiment I did in Spain, but in apples. So basically, we flew the drone there. We collect a lot of images from the apple orchards, and then we train a model, artificial intelligence model, to make yield predictions as well, but in this case for apple orchards. And we published an article as well, a paper, about this research as well. So that's basically what I did there. I also learned a lot of about how to manage with hyperspectral cameras, because in that moment they have these cameras as well. So that's the reason why I started to be more interested about. And then I will tell you about my current work in Jugend University. So it's related more or less with the hyperspectral cameras. Yeah.
Okay. So, could you also tell the listeners the implementation and challenges and the future directions in these orchards, especially AI implementation?
Yeah. Okay. Yeah. For example, let me tell you a little bit more about how we estimate the yield. So basically, we flew the drone. We took images from the crop, and then we train a model to be able to count the number of apples or orange, for example. Then, based on the number of apples or orange we can see from the drone, we are able to estimate the kilograms per hectare, for example, or kilograms per row or per meter, whatever you want. So that's the idea of that project. So the challenges in that sense is to have a good model able to generalize, to use in Spain, in Belgium,
Exactly.
and so that's the more tricky part. And I think you also have experience with machine learning and artificial intelligence. So that's the most important thing when you are trying to implement artificial intelligence is the data set. That's the key. If your data set is good, your model will be good as well. And it's even if you have a good data set, maybe you will have problems or you need to adapt your model to a new scenarios or new situations. So I think so that's the more tricky part. Moreover, now we have good models in terms of detection, but we need to go a little bit more deeper in that, because we need to offer solutions to the farmer. Because from my point of view, now we are like, okay, we have this, but the farmers are not happy is not the word. It's like they are not very interested, or maybe we didn't find a way to sell the product or to communicate our results to be implemented. So I think so. The second challenge is just how to teach these new technologies to the farmer and demonstrate how useful it can be for them. No, because at the end that's the objective. No.
Yeah, exactly. So you've been predicting yield.
Yeah.
Is it possible that maybe there is already research, I don't know, that they also detect disease?
Yeah, actually, it's like this project. It was sent for citrus in Spain. It started like to predict yield, and now I'm not participating in that project now, but I know my ex supervisor it's applying for a second round for the same point. They are trying to predict disease, but in this case, they are trying to use multispectral cameras because they are more accurate in that sense, and they can provide you more information as well in terms of the leaves, in terms of the disease as well. So yeah, that's a good good approach as well. Yeah.
Okay. So when I was preparing for the interview, I read a small part of your PhD dissertation where you mentioned that the mobile was used as an RGB camera.
Yeah.
So you used a mobile.
Yeah, mobile phone.
Mobile phone, just.
Yeah, mobile phone. Yeah, because basically, all the cameras from your phone are RGB. Sometimes the normal people, the general public, they don't know too much about multispectral or hyperspectral cameras. So basically, the camera we have, everybody has in your hands, is like RGB camera because they are able to watch in red, blue, and green. And yeah, then you can separate the bands as well. So it's basically everybody has a multispectral camera in their hands because the mobile phone is a RGB camera.
Yeah, for me, it's like I learned something new today. Yeah, we didn't know the power of like what we are carrying on.
Yeah.
Okay. You've also mentioned in that part where you've been mentioning about the mobile using developing that future trend could be that developing an app for this. Do you know someone who is already working on this, developing an app, or maybe you are working on this?
No. I know there is an institute in France making an application to estimate the leaf area index in this case, or to predict yields as well. But they are using trying to build a kind of software to be installed in your computer. It's not an app. But I know another application as well. So yeah, it's possible. It's you can go for that as well, but it's not difficult in that sense because the only thing is that you need to have time to go for invest to research a little bit more about, because if you want to build an app, what is the objective? Maybe to sell someone. So if you want to sell to the farmers, for example, that tool needs to be very good, because otherwise the farmers or the plant breeders will not buy the application. One of the things I like to say about that is like when you try to sell something to the farmers, you need to be very sure, because it's not like we are researching in the university. If the results are good or not good, it doesn't matter because, okay, that's part of the results. But if you're doing something to sell the farmers or to encourage the farmers to use this tool, you need to be very sure that it's working perfectly, because otherwise the farmer will say, okay, this is not good for me.
Yeah, exactly. If doesn't matter how high accuracy you have, if they cannot use it,
if they don't receive revenues, for example, they are not interested, of course, because it's like they want to earn money. That's the reason why they are doing agriculture, you know.
As always, Professor Abdul Mazen says, if farmer is not benefiting from it, they're not going to use it.
Yeah, of course.
The first thing is yield, or they have to benefit.
Yeah, totally agree.
Yeah. So you also gained an experience, and you are using the drone imaging. I just wanted to ask you, so what is the difference between using drone imaging versus the satellite images?
Yeah.
Because at the moment we have very high resolution satellite images as well.
Mm-hmm. Yeah, the most important thing, it's like the price, of course. We need to talk okay, let me start with this. We have to talk about the resolution. I think so. It's the most important thing. We have 4 types of resolution. And when we are talking about images, it doesn't matter if the images are coming from the satellite, from the drone, from the aircraft. It doesn't matter. It's the same concept. So you have the spatial resolution. It's about the pixel size, the measurements of the pixel. So for the satellite, as you mentioned, is like you can have as well high resolution, but maybe you cannot have high temporal resolution. The temporal resolution is how many images do you have each day from the satellite. Some of the satellites offer you images each 5 days, 1 day, 2 days. For example, the most famous constellation of satellite, the Sentinel-2, as you know. So this constellation offers you images each 5 days.
For free.
For free. So we have a temporal resolution in 5 days. Okay, there is another options, private options. They can offer each 1 day. But even if you have the access to that information, maybe the sky is cloud. So you cannot use the satellite because it doesn't matter how good is your satellite in terms of accuracy. So you need to fly a drone because the drones fly over the clouds. If you need, I not recommend you to fly using multispectral cameras when the sky is cloud, because the clouds can affect to the measurements. But that's one of the reasons why you cannot use all the time the satellite images. So you need to choose. And there is another problem as well, is the price, as you mentioned as well, because if you want satellite images with high resolution, it's a lot of money to pay, and you need to be a big company offering the services. It's not suitable for the farmers. Yeah, that's the reason.
Okay, so basically, first is the temporal resolution.
Yeah.
Second is the price, the limit.
The price as well.
Right?
Yeah.
And the resolution itself.
The resolution as well, the spatial resolution is
spatial resolution.
The spatial resolution is about the pixel size. And sometimes with the satellite, maybe, as I know, 0.5 is the minimum, as I know. Maybe 0.5. With the drone, you can 0.5 meters. But with the drone, you can obtain millimeters, maybe. Depends on the height of you're flying the drone. So that's the reason why you using the drone, because sometimes you need to be very accuracy. Because let me explain this, because one of the reasons why the people is using the drone now is not just to obtain images. It's also for applying, for example, fungicide, fertilizers. So if you want to use the drone for doing that, you need to be very precise, because otherwise it doesn't make sense to do with the drone, because you can do with the tractor maybe. So
yeah, exactly. So it depends on your the objective of your research. At the same time, how much resolution do you need? For example, if you're working in a big field and you don't need too much a high resolution, maybe it's better to use it.
It's not about the field, it's about the crop, I think so. If you are working with wheat, for example, so in that case, you can build management zones to apply just in that part of the field, Maybe you can separate, imagine two zones. One is the healthy zones and the other is the disease zone. So the ideal situation is just to apply and that zones with high percentage of the disease. Or maybe change the dose of the product to apply more when you have more probabilities to have high percentage of the disease, then reduce in 20% or 25%, and those zones with a medium percentage of the disease. And maybe you can think, if it's possible, don't apply anything if you have low risk of the disease in certain parts of the field. So if you are working, for example, with orchards, you have individual plants. So you can apply just in those trees, for example, with disease, and the rest of the trees, maybe you don't need to apply anything.
Okay.
So that's the reason why the accuracy is important in that sense.
So you've also mentioned earlier about farmers needing that something has to be needed or meet the needs of farmers. What about drone imaging? Can farmers afford drone imaging?
They can, but as I see, this is like you need to think about the new technologies as a service. A lot of farmers are making a kind of cooperatives, for example. So they are, they work together as a farmers, and so they have a kind of representation called cooperatives. It's like it's work in Spain, for example. We have a lot of farmers. They belongs to a cooperative. It's a kind of organization. So this organization provide the agriculture technicians. They provide the sellers for the product. For example, they negotiate with the supermarkets, for example, if you want to sell the orange to the supermarkets. And so the cooperative talk with the supermarket, so they have more power in that sense. So my vision about the new technologies is not just about artificial intelligence, is that you need to talk with the cooperatives to put the service in the cooperative. So then the cooperative can share the service to all the farmers that belongs to the cooperative. So in that way, it's more easy for them because, for example, imagine you have a drone pilot in the cooperative. So this drone pilot can fly all the fields for all the farmers, maybe two. It depends on the site of the cooperative, of course, but it's not for each one of the farmers, because I think it's the same concept with the harvester machine, for example. Not all the farmers have the harvester machine. They used to rent the harvester machines when the harvest season is coming. So
provide the service if you
so
have
provide the service. So that's the drones can be used in that way as well.
I know that in Spain it's they have very big cooperation of farmers.
Yeah.
I'm not sure if it's the same for other. I got your main idea that if the farmers unite, they can use each other's equipments. It would be much more available.
Or maybe the same. The sellers used to be more or less the same. In the area. Maybe the sellers can provide this kind of service, or maybe you or me, we can build a company to serve the farmers. Why not?
I would be happy to. Yes.
Yeah, that's the idea, I think. So we need to put out our minds that idea of, no, this is for the farmers. Or maybe, for example, you are using a kind of sensor to monitorize the soil, for example. And maybe this can be sold to the farmers as a service, not like for each one of them, because it's impossible, I think so. It's the same concept as I mentioned with the harvester machine.
I see. Can we conclude then that this AI technology and robotics, everything that is up-to-date technology now entering the agriculture, and there are lots of possibilities for researchers, for business ideas as
Yeah,
well?
actually, I think the robotic and artificial intelligence is starting to go faster, especially in that areas like greenhouses and indoor facilities when you are able to cultivate crops, because the conditions are more controlled in that case, because for example, if you put a robot in wheat fields, for example, or maize field, it's more complicated because it's outside, it's outdoor, so you need to be and the crops is changing all the year. However, in the greenhouse, for example, everything is controlled. It's more or less the same area. So, in that kind of facilities, the technology is coming very fast. And it's actually, you can go to the greenhouses, for example, you can see a lot of robots working, um, a lot of technology for predict what disease, whatever. So that because the environment is more controlled, it's the crops as well. The value of the crops is expensive as well in comparison with the wheat. If you compare wheat with strawberry or or blueberries, for example, it's the difference in terms of price is huge per the kilo. I don't know how much is the cost per hectare or the benefits from wheat, but it's the double or 4 times more in comparison with a strawberry. So in strawberry, you can find, for example, a lot of robotics technology, artificial intelligence, because it's really important to the farmer to have a good predictions of the yield, for example, or to mechanize the harvester as well. So in that kind of crops, you can see now if you not in all the greenhouses, but you can find a lot of examples, commercial examples for.
Okay. And the big fields, there are lots of challenges, of course.
Yeah, of course, yeah. And the big fields, but they are starting as well, especially in those countries with big areas like Brazil, for example, Australia as well, because they have, this is like, I don't know, which is the average in terms of area here in Belgium.
I guess,
farmer.
Sorry to interrupt. Australia, it's a little bit complex tricky, because even though it has a big area, most of them is just a desert. They don't use it. So they're a very small area for the agriculture.
Yeah. But in Brazil, for example, yes, they have a lot of, the soya crop. Yeah, they have a big area, so they are using a lot of technology as well. Actually, yesterday I was watching some videos on TikTok, and when they are using the drone to apply nitrogen. So, and
in the field.
In the field, I can share with you later because it was very impressive because they use a kind of robotic platform, the drone platforms. They have the same system that you have in the tractor, this kind of, I know how they...
sprayer?
A sprayer fertilizer, the urea. Urea is the urea. So they basically apply the urea in that way from the drone. And
but it's quite heavy though.
Yeah, but they need to pass a lot of time, it's like, but sometimes because they have wet conditions there, they cannot go inside the field and in certain moments when it's raining a lot, but they can fly the drone, for example.
That's great because just this year I had that problem actually. We couldn't enter the field.
Yeah.
Especially when you enter the field, actually with the machinery, you are compacting the soil. So with drone, it's...
Yeah, I was very surprised because I saw how they are using this technology, because I know they are applying fungicide, but it was very interesting to see they are also applying fertilizers. That's
the future trend. Okay.
Yeah.
My job is already outdated.
You can try next year maybe.
Okay. Yeah. Now, why do we hear a lot about AI and robotics in agriculture? Again, we are coming back to the same question, but to summarize, but there is less application of them via farmers.
Yeah, the main reason I think is because the technology is not robust yet in terms of, as I told you before, it's like you need to demonstrate the solution is working perfectly. And sometimes the human's labor is more accurate in that sense, more quickly as well, and sometimes cheaper. Depends on the country. For example, in Spain, we have sometimes in during this harvesting season, we have a lot of people coming to Spain, for example, to work. So this sometimes for the farmer is cheaper to contract them, and it's to invest in new technologies, expensive. But sometimes I think it's also you cannot see a lot of technology in the field because the farmers are concerned about the people is working with them, because you cannot change everything today for tomorrow, it's like, the people is also important for them, if they don't want to replace them immediately. So it's like the industrial revolution, in the past, if you read the books, they say a lot of people was very worried to lose their jobs or something like that. So now we are living that kind of problems as well. Actually, I have the opportunity to teach lessons in Seville. And when you talk with the students, they say, "Oh, we will not have job in the future because if the robots are doing all the task, what happened with the people is working?" Yeah, but I don't see in that way as well because maybe you need to change your background or adapt your background for the future as well. So yeah, but the technology is coming step by step. Now after the pandemic, it's growing very fast, but yeah.
Exactly. After pandemic, even people got more open about AI and implementing all the...
They are more open even for everything, for the technology. Yeah.
Exactly. Yeah.
Yeah.
That's true. Thank you for answering all the questions and having a nice conversation. I want to ask you now some general questions.
Yeah.
Yeah. Okay. There is no right answer. It's just your opinion. Can AI replace humans? And how far are we from this happening?
No, I don't think so. Basically because you need humans to program them, of course. Moreover, I think so there are certain rules as well, and we need to avoid to skip the rules because otherwise, I think so. I know to be an optimistic, but otherwise we will disappear from the planet. It's because if we give the power to the AI to replace us, it's not
Do
possible.
you think, like, at all, do you think that there would be a day, doesn't matter when, but in the future, somewhere in the future, AI could replace? Or you totally disagree with the opinion?
I'm totally disagree because it's difficult. It's difficult question. I hope, or maybe I will not see that, but I hope it's not happening.
I can relate why you feel that way because I used to tell that people who doesn't work with AI, who have no experience working with AI, they're very scared about it. Once you start working with AI, like you implemented AI in your research, they're not scared.
Yeah, basically because we are very far, if you watch some movies, we are very far from that. It's impossible. And if you watch Terminator, for example, is the most famous film, maybe it's a little bit old in that case, but we are too far from that situation, that moment. I used to tell my students when I used to teach lessons, like Skynet is the robot in that movie. They start to control everything. We are very far from that. It's because basically we are teaching the AI. Yeah, but it's complex. It's complex. I don't have a unique answer, but I hope that moment is not coming. But but to be honest, we don't need to be scared today about the AI because I think, especially in Europe, we have a lot of rules. The European Union is trying to restrict how the AI is working as well. Yeah.
Do you think, just a follow-up question, that ChatGPT can replace teachers, maybe somewhere in the future?
No, because you need to not replace, but let me tell you my opinion about ChatGPT.
Okay.
I think ChatGPT is a good tool. It's an amazing tool. Actually, I started to use 1 month ago because when they launched the application, I said, okay, let's see. But one of the day I started to use it, say, oh, it's good. Yeah, it's good. It's because you can save a lot of time. This tool gives you a lot of quick answers, but you need to think as well because I have teaching lessons as well. It was very curious because we were programming a kind of Arduino. The objective was to switch on a red LED and switch off green LED. So all of the students start to use ChatGPT and they say, give me the code to do this. So, okay, ChatGPT gives them the code and they say, Enrique, this is not working. So why is not working? Because the reason was because the ChatGPT doesn't know where you connect the LEDs. So ChatGPT gives you the code, but you need to think a little bit about what are you doing, because otherwise it's not make sense. So I think ChatGPT is good, but maybe it will be a problem for those people lazy. Let me say lazy, because they don't want to think a lot. But for in our side, for example, we are researchers, it's a good tool, I think so, because we don't trust in anything from ChatGPT. We always check it's right, it's correct. So, but it helps a lot as well, because sometimes you need to summarize the text or something. Yeah.
Yeah, I think it's a great tool for where you don't have to think. You just need a quick reply, but you know that that area. You know what is it. So it's repetitive tasks.
Yeah.
Let's see. Okay. Is it essential to learn coding skills for incoming PhDs in agriculture? And what can one person miss with having no skills in programming or AI?
Yeah, I think it's in this new era about technology, I think so it's compulsory to have certain knowledge about programming. You don't need to be an expert, of course, especially if you are working in the agriculture sector, but at least you have to have certain knowledge about how to communicate with another experts. For example, in my case, I'm an agriculture engineer. I'm not mechanic or electrician engineer or informatic, for example, but I think I have certain knowledge to communicate in a good way with the guide expert and how to develop a web page, for example, a cloud or even advanced machine learning models, or how to deploy. So I think it's at least you have to learn the basic things when you talk about the data, for example, it's like a flow data, Boolean data, what it is, no? It's like, or integer data or string. If you know at least that things, it's good. But I think the programming languages or everything related with the codes, for example, it's also important because gives you another perspective about how the things work, or how can we do the things in a effective way as well. Because sometimes we spend a lot of time, for example, if you are using Excel, for example, everybody knows Excel. But if you have experience with Python or R, for example, you can do that very fast and very accurate as well. So that I think it's, if someone start the PhD without experience, I recommend without experience in programming, for example, I recommend them to start a little bit. Yeah, but of course, then there is future for them as well if they don't know. But I recommend to learn.
I guess in general in agriculture, because we are shifting towards the big data and the implementing robotics and AI in the agriculture. Okay.
Yeah.
Any advice for young PhDs?
Be patient. Yeah, because sometimes it's very hard. I know, because the first year and the second year was, for me, was the worst years, but it was the more intensive, because you are starting. You have to correct all the experiments. Moreover, in the agriculture sector, you cannot control everything, because it's like the weather. Sometimes it's raining, sometimes it's hard. You're planning to apply tomorrow, but it start to rain.
That's true.
Or sometimes you lose the data as well. That's a big problem, because
weather doesn't care about your research.
Yeah, but sometimes, I remember, for example, the first year, I forgot to measure one of the days. And then I have a lot of problems to justify that day. Why you didn't measure that? But it was impossible, because I didn't have time to do that. So it's on the case. Yeah, but be patient and work a lot, because when you start the PhD, it's because you want to research forever, I think. So actually I have My mother, for example, always say, Enrique, when you will finish? Because I start my bachelor in 2011 and we are in 2023 and say, when you will finish, Enrique? I don't know. Well, this is forever. I think so because it's always doing more or less the same. You have to, yeah. So be patient. But all the things I like from research, PhD is like you always are learning. So that's basically that's one of the reasons why I start in this position because all the days you are trying to, yeah. Sometimes it's the same task, but all the day you are trying to learn a little bit more and bit more, bit more. So that's good for me. That's the reason why I'm doing the postdoctoral as well. And yeah.
I see.
Yeah.
Thank you so much for sharing with a lot of useful information and about your PhD dissertation topic and experience. That was a lot to learn, I guess. Our listeners enjoyed, and especially for those who are coming in this area. I know a friend of mine who wants to use drone imaging. So I guess, yeah, for people who like her, there would be a lot of information. Thank you a lot.
Thank you so much, Natalka. It has been a pleasure to be here in the podcast, and thank you so much.